Okay, 10.3, applying properties of chords. So a chord, it goes back to our 10.1 definitions. So a chord has 2 points on the circle and it's a segment. Remember that definition. We have 4 different theorems. First theorem says 2 minor arcs are congruent if and only if their corresponding chords are congruent. Remember, if and only if goes both directions, which means if the arcs are congruent, then the chords are congruent. Or if the chords are congruent, then the arcs are congruent. So there's the words, here's the pictures, and again, it can go either way. So if AB and CD, these 2 arcs are congruent, then that means chords AB and CD are congruent. If chords AB, CD are congruent, then arcs AB and CD are congruent. It works both ways. So look at example 1. They're asking us to find the measurement of AB, refreshing your memory from yesterday. That M means we're looking for a degree measurement. So how do we go about finding the degrees of arc AB? How do I do that with what information is given to me?
So the 100 degrees is that arc, so you do like 360 minus 100 and then divide that by 2.
Good. So we know that this is already given to us as 100. 100 plus this arc has to be 360. So we know that because these chords are the same, these 2 arcs AC and AB will also be the same. So if we just do this in our head, 360 minus 100, what does that give me? 260. 260 divided by 2? 130. So this arc's going to be 130 degrees. My next theorem, orange theorem. It says if a diameter is perpendicular to a chord, then the diameter bisects the chord and its arc. So notice this is my diameter, there's our center. So if the diameter meets this chord at a 90-degree angle, it's perpendicular, then it divides that chord into 2 equal pieces. It also divides the arc into 2 equal pieces. So if we know it's a diameter, meets it at 90 degrees, it bisects the chord and its arc. So look at this example. It says find x. So looking that this is a diameter, we can tell that because that's the center. This is obviously a chord and it meets it at 90 degrees. Because it meets it at 90 degrees, that means that these 2 segments are the same, which allows me to set them equal to each other. So be careful that you don't just kind of randomly put things equal to each other. Understand why. So how do I solve this? What's my first step? How do I solve it?
You said, minus 6x.
So if I move my 6x over by subtracting, I get 2x here. Now what?
You add 5 to both sides.
So what's my answer?
3.
Good. Be careful that you're answering the questions. The directions ask you to find for x, and we did. Moving along to our red theorem. This one says if a chord is a perpendicular bisector of another chord, then the first is the diameter. So I can see that there's 2 chords drawn. They meet at 90 degrees and one is cut into 2 equal pieces. That allows me to say the one that's doing the bisecting is the diameter. So notice it's 2 chords. The one that's being cut is not the diameter. The one that's doing the cutting is the diameter. We're allowed to call it diameter because of this scenario. Look at my example. We need to decide if QS is a diameter or not. What do you think? Yes or no, and why? What do you think?
Because it's the one that's the bicep.
I actually called on you. That's okay. Go ahead. It doesn't matter.
Because it's the one during the bicep. No.
So are you saying yes or are you saying no?
No.
Okay, tell me why no.
Because QS is the one bisecting beyond.
Okay, well that's good. That's what we want. So if the diameter is doing the bisecting, it has to meet it at 90-degree angle, the other chord, and it also has to divide that chord into 2 equal pieces. Is that what's going on here?
Yeah, no, so QS is a diameter.
It is or it is not?
It is a diameter.
It is not. Because we have 2 chords. They're meeting at 90 degrees, great. But we also have to know that this diameter is cutting this chord into 2 equal pieces, and it is not. So because this one's 19 and this one's 20, it's not a bisector, which tells me that QS is not a diameter, and that's a no. Do you see it now?
Yeah.
Okay. Anybody else confused on that? So in order for that QS to be a diameter, it has to cut that other chord exactly in half, and it has to meet it at 90 degrees. This one met at 90 degrees, but it didn't divide it into 2 equal pieces. Okay, one more theorem. This one says 2 chords are congruent if and only if they're equal distant from the center. And remember, distance has to be perpendicular. You're never going to have distance that goes in a meandering kind of way, or think about if you're starting at a point and you're going somewhere over here, that distance is never going to look like that. That distance is never going to look like this. It doesn't make any sense. Distance always has to be perpendicular. So if you're starting here and going to this place, it has to be perpendicular. Always, always, always. So when we're talking about the distance from a chord to the center, it has to be perpendicular. When you're thinking about this theorem, keep that in mind. So it says if the 2 chords are congruent, this distance and this is the same, then the distance from those chords to the center have to be the same. But distance does have to be perpendicular. So if the chords are the same length, then they're going to have the same length and perpendicular distance to the center. This one's a little bit tricky. And because it's if and only if, it goes both directions. If we have 2 chords that are perpendicular, same distance to the center, then that tells us the chords are the same length. The chords are the same length, then there's going to be perpendicular and equal distance to the center. Take a look at my picture. So look at what's given to you. Here's my center. Here's my 2 chords. What's given to me is from each chord to the center has a length of 4, and it's a perpendicular distance. So we're going this direction. We know this, therefore we know this. So if I know KL is 7, what does HJ have to be? 7. But again, don't just kind of guess at that, understand why. The reason why these two chords are the same is because they are perpendicular and equal distant to the center. It's because these are perpendicular and they're both 4. Okay? And now we have a proof to do. This is going to be hard to do. Okay, take a look at my picture. The given information, it says PQ is the diameter of circle U. They also tell us that arc PT and arc QS are congruent. So I have those marked on our picture. With any proof, we always want to start by writing our givens down, so do that with me. I'm going to rewrite my givens. PQ is the diameter of circle U, and my reason is given. Arc PT is congruent to arc QS, and that's also given. We're being asked to show that this triangle, I don't have that center to U, PUT and QUS have to be congruent. So this is relying on stuff that you guys should already know from previous chapters. So what do you see as a good starting point, or just even a wild guess of where we can go? We need to show those 2 triangles are congruent. Any wild guesses? Remember, the givens are kind of a push in the right direction. So what do the givens now lead you to believe? Go ahead.
The angle's the same, and then
What angle?
the QUS and PUT,
Why is the angle the same?
because the arc angle are the
I
same.
like that. I haven't thought of it that way. So she said because this arc QS is the same as arc PT, that allows me to say that these 2 central angles are the same. So we're going to say my angles are the same. So angle PUT is congruent to angle QUS. What's my reason for that? Well, it'd be a reason that says that these 2 angles are the same.
Oh.
I would say definition of central angles. Okay, that's a good starting point. So now we have angles the same. What do you see?
PU and QU are equal distance
How do you know?
because U is the this side, or the
What can we call PU and US? Or I'm sorry, PU and UQ.
the bisector
Not quite.
chords.
They're not chords. This isn't a chord. I heard it. It's the radius. So PU is a radius and UQ is a radius because any point from the center to a point on the circle is called a radius. So we can say definition of radius for this one. So we have a side, we have an angle, we need one more, at least one more. What he just said should lead you to a next statement. What do you see? I agree. Explain why. You're right. Well, actually, I'm just going to keep this as a continuation to the last one. We'll say UT is congruent to US for the same reason. Those are both also radii. Now we can say those two triangles are congruent. What's my reason? Yes. So triangle PUT is congruent to triangle QUS because of side angle side. Remember, side angle side has a relationship where the angle is smushed between the two sides that are congruent. So this is a side angle side relationship. The other way you could look at this is, which is the way I did it, you could say that arc PT and arc QS are congruent, which allows us to say chord PT and chord QS are congruent using one of our new theorems today. That would allow us to do side instead of side angle side. It's another way to look at it.